Hey everybody, so here's an interesting problem. Let's give it a try. There's a frame with a distributed load, and we want to solve for the internal forces and moments. Okay, so for a frame, what do? Let's break it apart. Okay, so then there's this member up here at the top, and then this kind of diagonal one, the one kind of at the bottom, and then this one over here. Okay, so then there is a pin here, here, here. Let me just point out all the pins, the pin joints everywhere. Okay, and then there's that distributed load over here. Okay, so there's a bunch of forces acting on this member. Three forces acting at 3 different points here, but only 2 points here. So that's got to be a 2-force member, right? It's either like this or like this. Those are the only 2 options. Similarly here, there are forces acting at only 2 points. So it's either like this or like this. Those are the only 2 options. Okay, so why don't I label it like that? Let's see. Let's give these letters. So there's A, B. I'll just call this C and D. So if this is C, this has got to be equal and opposite. This is D. This has got to be equal and opposite. Okay, and then this pin connects here. So these have got to be equal and opposite. This pin connects here. So it's got to be like this. This pin connects here. So it has to be this way, and this pin connects here. So like that. Okay, let me just move these out of the way so we have more space. Okay, and then there's a pin. I'll just call this point E and F, or how about G? Since F is like force, I'll call this E. Let me pick coordinates. Okay, so if I call this pin E and pin G, I'll decompose the reaction at pin E into X and Y components. And then at pin G, I'll decompose that into components. Okay, so now, let's see, we have 1, 2, 3, 4, 5, 6 unknowns. And we can write 6 equations, which means we should be able to solve for everything. Okay, so X direction. Let's see. Okay, so first of all, see this distributed load? I can represent that distributed load as a single discrete force. The magnitude of the force is the area of the shape. Right, so there's 3 and 4, so that's 12. And the location of that force is at the centroid of the shape. So it's a rectangle. That was 3, so this has got to be 1.5. Okay, so now some forces in X, EX. Let's see. So see this angle right here is right here. So let's see, tangent is opposite over adjacent. Okay, right, so we know the angle. So this angle is known. So then in the X direction, EX minus C cosine theta equals 0. Okay, Y direction, EY minus C sine theta minus D minus 12 kilonewtons. And let's sum torque about somewhere clever. Okay, how about over here? Okay, so the torque from D would be negative 3 meters. The torque from C is, how far is that? 2 meters. And then only this component provides torque, so only the C sine theta component. And then this is minus 1.5 meters, 12 kilonewtons. Okay, let me point out the unknowns. Okay, so we're not able to solve any of that right now. So let's go on to this member of the frame. Okay, so, and then again, we know this angle right here. Okay, so x direction, gx plus c cosine theta. Y direction, gy plus c sine theta plus d. Let's sum torque about, how about over here? Okay, so torque from that would be positive 3 meters d, and then plus here to here is 1 meter. And then only this component of C provides torque about this point. Sine, and let's see, that's pretty much it. Okay, let me point out the unknowns here, here, here. Okay, so how do we solve? Let's see, so look at this equation here, this equation here. Two equations, two unknowns to solve for C and D. So for example, you say C is minus 3D. And then take that and put it right here. Right, then this is only in terms of D. Solve for D, and then plug it right back in here, and you have C. So now we know both C and D. And if you know both C and D, right, look, then you can solve for GY, you can solve for GX. If you know both C and D, you can solve for EY, you can solve for EX. So now you know all 6 unknowns, all six unknowns, right? Solved it. Okay, now let's move on to the internal forces and moments, right? So if we want A, let me draw that, right? It looks like there's GX, GY, C is over here, D is over here. We know all of these values, right? We know all of the values. And then point A is right there. So we cut a section right there. And the left section looks like this. And then all the internal axial force, shear, bending moment. The right section looks like this. Axial force, shear, bending moment. Okay, so which section would you like to analyze? I think this one looks simpler, right? So let's go with that. This section. Why not, right? Because you're going to get the same answer either way. Okay, so x direction. Again, my coordinates were this way. So x direction minus p. Is that it? Yep. Okay, y direction, v, d, 0. Some torque about wherever we want. How about the left side? How far is this again? Okay, so here to here is 2 meters. Here to here is 1 meter. Okay, so 1 meter times d. And then, again, z is this way, the way I pick my coordinates. So that would be in the negative z direction. And there you go, right? Let me point out the unknowns here, here, here. Right? Solve for the axial force, solve for shear, solve for bending moment. Done. Okay? And then let's do the next problem is this one. Let's do that on a separate video. So see you on that one.